If you want a few more examples with L'Hopital's rule, here they come, 4 more for you. If you're going to use L'Hopital's rule, really we should make sure that we verify every single time that you have something that's indeterminate. So the limit as x goes to infinity. If we think about this natural log of 2x, as it goes towards infinity, we're going to get infinity. 2 radical x, as we go towards infinity, we're going to get infinity. Indeterminate. So we can use L'Hopital. Limit as x goes to infinity. Now we're going to take the derivative. So this is 1 over 2x times 2 over. Now this is going to be 2 times, this is x to the 1/2 x to the negative 1/2. This is equal to the limit, just to clean it up a little bit. As x goes to infinity, 1 over x divided by, this is just 1 over the square root of x, which equals to the limit as x goes to infinity, and this is going to end up being radical x over x, which, if you really wanted to, you could say that this, because this is like x to the 1/2, right? So just subtracting exponents, this is x to the negative 1/2, which is equal to the limit as x goes to infinity of 1 over the square root of x. And when you plug infinity there, you're going to get that this limit approaches to 0. Okay, love it. Now let's check here. We plug in a half. What are we going to have? A half times the cosine of pi over 2. Cosine of pi over 2 is 0. Now here, e to the 1/2 minus e to the 1/2 is 0. Indeterminate. So we can use L'Hopital's rule. Limit as x goes to 1/2. We need product rule here. First times the derivative of the second. It's going to be negative sine of pi x times pi, chain rule, plus second times derivative of the first, that's just 1, all over e to the x, and that's going to be minus 0. That's just a number. It's not anything but a number. It's a constant. So we can clean this up a little bit just to make it look a little bit prettier. 1/2, we're going to have negative pi x sine of pi x plus the cosine of pi x all over e to the x. And now we can plug in 1/2, direct substitution. Negative pi over 2 times the sine of pi over 2 plus cosine pi over 2 e to the 1/2. Sine of pi over 2, that's up here, right? And that's the 0.01. So sine of pi over 2 is 1, so that's just negative pi over 2 plus 0. E to the 1/2, yeah? So this is just equal to negative pi over 2 times, over square root of e, which is negative pi over 2 square root e. That's the value of this limit. How beautiful. 2 more to go. 2 more to go, and just 1 more lesson of videos. This is exciting. Okay. Let's check this one out. If we plug in 0 for x in the numerator, we're going to get 1 minus 1, which is 0. And now here, natural log, 2 minus e to the x. If we plug in 0 for x, we're going to get 1. 2 minus 1 is 1. Natural log of 1 is 0. What do you know? Indeterminate. Because it's indeterminate, we are allowed to use L'Hopital's rule. So limit x goes to 0. Derivative of the numerator is just negative e to the x. Derivative of the denominator, natural log, we take 1 over 2 minus e to the x times the derivative of what's inside, and that's just negative e to the x. So this whole thing is equal to the limit as x goes to 0, negative e to the x over negative e to the x over 2 minus e to the x. I didn't really need to do that step, I guess, but this, thinking about how you deal with fractions, e to the negative x times 2 minus e to the x, negative e to the x, these two divide out. This is equal to the limit, x goes to 0, 2 minus e to the x, direct substitution, 2 minus 1. This limit is equal to 1. Just plain old number 1. One more here. One more. Limit x goes to 0. Well, let's see. If we plug in 0 here in the numerator, we're going to get 0. And here, sine of 0, indeterminate. So we can use L'Hopital's rule. Limit x goes to 0. Product rule for the numerator. First times derivative of the second plus second times derivative of the first. Product rule again. First times derivative of the second plus second times derivative of the first. Now, let's see what happens if we plug in 0. In this first term, we're going to have 0 plus cosine 0. This is going to be just 1 times cosine of 0 plus sine of 0. And the numerator is just 1, denominator is 1. This whole thing is equal to the number 1. And that, my friends, is L'Hopital's rule.